In this video, we're going to look at how to figure out the first term and the common ratio of a geometric sequence if you're given any two random terms. So in this case, we're given the sixth term and we're given the 11th term, but we don't have the first term, we don't have the second term, we don't have the common ratio. It seems like we have very little. How should we approach this question? Well, we do know the relationship between any term, which we'll call un, the nth term, and the first term, and the common ratio. So that is the general term formula for any term of a geometric sequence. Again, that's the general term formula for any term of a geometric sequence. And that's going to be very useful for us. So, how do we use this? Well, what we're going to end up doing here is writing down what we know into the general term formula. So we do know that U6 should give us U1 times the common ratio raised to the 6 minus 1 power. So the sixth term is U1 times R to the 6 minus 1 power, according to our general term formula. And we know that the sixth term is 24. So 24 is U1 R, and we can simplify that 6 minus 1, and we get 5. On the other hand, well, here we still have two unknowns, and we have so far only one equation. So on the other hand, we can do the same thing for the other term that we have. U11, the 11th term, is equal to U1 R to the 11 minus 1. And we do know that U11 is 768. So 768 is U1 R to the 10th power. So now we have two equations with two unknowns. And that means that we are able to solve these two equations simultaneously. So you want to stack them one on top of the other. You want the one with the bigger exponent on top. So 768 equals U1 R to the 10th is our first equation, and 24 equals U1 R to the 5th is our second equation. Now, in order to solve this, we want to eliminate one of our variables. If we divide these two equations by each other, we will automatically eliminate U1. So we're going to divide everything by each other in these two equations so we can eliminate U1. So 768 divided by 24, and do this along with me, on the left side you should get 32 when you divide those numbers. Now, for the R to the 10th power divided by R to the 5th power, you need to recall that when you're dividing, you have to subtract your exponents. So in order to divide those two numbers, R to the 10th and R to the 5th, those two terms, we have to subtract the exponents. And we get that, we get R to the, we get R to the 5th on the right side. Now, that means we're almost at the end. The opposite of raising something to the 5th power is raising it to the 1/5 power. Or we could take the 5th root. Same thing. So if your calculator doesn't have a 5th root button, if you're not working with a TI-84, or you don't know how to find the 5th root in your TI-84, feel free to just raise this number to the 1/5 power in order to solve for R. And once you've done that, you should get that R is equal to, and I'm doing it in my calculator right now, R is equal to 2. So that means that 2 to the 5th power is 32. And you can check it out, right? 2 to the 5th power, 2 times 2 times 2 times 2 times 2 does in fact give you 5. So therefore r is 2. Now I don't want to turn the page to erase all the beautiful work that we've done so far. So in order to figure out u1, I'm just going to do it on the left side of our page. So now to figure out u1, we can pick either equation. We could pick the one on the left or the one on the right. The one on the left seems a little simpler, so I'm going to work with that one. So we know that 24 is equal to u1 times r, which happens to be 2, to the 5th. Now, we just spoke about the fact that 2 to the 5th gives us 32, which means that 24 equals u1 times 32. In order to figure out what u1 is, we're trying to isolate it, which means we have to divide both sides by 32. And we will get that u1 is equal to 0.75. So now we know u1 and we know r. The final part of our question asked us to give the general term. And once we know u1 and r, that is very simple. We just have to go back to the original general term formula, which is un equals u1 times r to the n minus 1. That's our original general term formula. Well, that's not the actual answer in this case. The actual answer for this particular formula, we have to plug in what we know. And we know that u1 is 0.75. And we know that r is 2. We don't know n, so now we can raise that to the n minus power. And that's the general term formula for this sequence. And we're done.